Hello students, so today we're going to look at what is known as functions. And functions are pretty new, not too new from Algebra 1, but we're going to look at some more complex ones. Here are two very complex functions that we're going to look at this year. So one in particular is known as a logarithmic function, and another one is a trigonometric function. So let's first look at our learning targets. And basically, we're going to answer, what is a function? Here's your learning targets. You're going to need to be able to state the domain and range of a relation, determine if a relation is a function, read functions written in function notation, evaluate functions accurately, and determine if a relation or a graph represents a function. So you're going to want to view functions or view these like a function machine. So you have your input values. Let's say they're 1, 2, 3, and 4. And you're going to put them into our machine, which is our rule. Our rule, let's say, is 2x plus 1. Well, every time I put an input in, I should get an output value of 3, 5, 7, and 9 because I took the 1 and put it in for the x and I got 3, right? So this is what's known as a relation. And go ahead and write this definition down. A relation is a set of ordered pairs with a domain with x values and a range of y values, all right? So here's the mathematical definition of a function. A function is a relation where each value in the domain is paired exactly with one range value. So one domain value is only to one range value, okay? So consider this water machine here. Let's say that I know that two buttons can lead to the same output, right? Notice how I have two water bottles here, two water buttons. If I push either of those buttons, assuming it's the same kind of water, I should get water back out, right? And it doesn't matter. That's good. That's fine. So I have input values that are the buttons that I'm pushing, and then my output is the beverage that's going to come out of the machine. Now, what's going to happen if one button leads to two different outputs? Let's say that I'm going to push one of these red buttons right here. And let's say one of my friends goes first and she gets a red Gatorade, exactly what she wanted. And then let's say I push the red Gatorade button, I get a green tea. That's not right, right? I wanted red Powerade, not green tea. So what's going to happen is we would think, well, it's broken. So we're going to think of it that way for functions. Here's some other real-life examples for functions. So one that is a function is a state in capitals. Each state has only one capital. I can't have more than one state with more than one capital. So, like North Dakota has Bismarck. It doesn't have any other capitals. But here's a non-function, a state and its senator. Each state has has two senators. So in North Dakota, we have Governor or Mr. Hoeven and Mrs. Heitkamp. So I have two input values going to a different output. So one input going to two different output. That can't be. I can only have one input going to one output. So let's take a look at how this actually looks. You're going to see it in three different ways. You're going to see one as a table. So your domain is your x values, which is 0, 1, 2, and 3, right? So it says in the x column you have your x domain. Your range is -7, -4, -1, and 2. Notice how I went in increasing order, okay? So let's look here. Does this relation meet the function criteria? Do I have each domain value going to only one range value? The answer is yes. There's no problems here. What about a mapping diagram? You probably haven't seen these as much in your academic career, but that's what it looks like. Basically, it's two circles, and it has some stuff written in it, and then there's arrows pointing who relates to who. So my domain in this one is 1, 2, 3, and 4. Notice how it's the x side, or the left-hand side. It's what the arrows are pointing towards. Your range is B, C, and D. So then we're going to look here and see, is this a function or not? So do I have more than one x value going to or do I have one x value going to more than one y value? Well, notice how I have two x values going to one y value. That's like the two water buttons going to just water. That's fine, right? So that's also a function. Now you're saying, well, is there one that's not a function? What's going on? Well, let's look at this one. So my domain is -8, -5, and 7, the left-hand side one. And then my range is -6, 1, 2, and 3. Now, notice how -8 is going to 2 different values. That's not right. That would be me pushing the red Powerade and getting red Powerade and then getting a green T. So that's not a function. Another example is when you just have ordered pairs. I find the best way to do these to see if I have a function or not is to make a mapping diagram. So to put my x values in one, I'm going to put -2, 0, 4, and 5. And then my y values are going to go in the other one. Notice how I didn't write 2.5 twice. I'm just running it once. Then I'm going to start matching my values. So -2 is related to 0.5. So he's going to go over there. And then I have 0 is to 2.5, which is right there. 4 is going to 6.5, and 5 is also going to 2.5. Notice how I have my domain in one area and my range in the other. So my domain is, of course, -2, 0, 4, and 5. And then my range is 0.5, 2.5, and 6.5. Now, I need to think, is this a function or not? So I'm going to look, do I have one x value going to 2 different y values? No, but I do have the opposite. I have 2 x values going to 1 y value. Remember, that's like the water, 2 water buttons going just to water. That's fine. So that's a function. Now, we're going to also look at function notation together. Function notation is basically a fancy way to write y, but it's going to be a very common way that we're going to see y now. So function rules are often written with function notation. So each function is going to be given a name. In this particular, his name is f. So right here, I have a name of f. Kind of like my name is Alicia, and your name is possibly Bob. So that's the name of the function. X is the input value. X is whatever we're going to put into our function named f. And 3x plus 4, that's the rule. That's what we're going to do. So I have an x, let's say it's 2. I need to put, they want to know, what if x is 2? What do I do? How do you read f and parentheses x? Basically, that is not f times x. That is the value of f at x, or f of x. I'm going to use f of x very commonly. That's how I'm going to say it. But if you need to think of it as the value of f at x to help you think, to not do that multiplication thinking, by all means, whatever works for you. So let's take a look at evaluating some function rules. So there's 2 ways you might see it. You might see the old way, which is evaluate for x at -2. So that means I'm going to take this -2 and pop it in for x right there, right? So f of -2, notice how I put the -2 in there, right? So I'm going to go -3 times -2 plus 7. So -3 times -2 is 6. And 6 plus 7, well, that's just 13. So at -2, it is 13. Now, notice on this one, they don't tell me what to plug in. They don't say x equals, but in a way they actually did. So you notice how there's an x here, and then I have a -1. Technically what it's saying is, into function g, put -1 where the x is. So that's what I'm going to do. I'm going to say g of -1 equals -1 squared plus 2 times -1 minus 10. Notice any time I had an x, I put a -1 in there. So let's do the math here. -1 squared, that's 1. 2 times -1 is -2 minus 10. So 1 minus 2 is -1 minus 10, or -11 actually. Pretty easy, right? It's just making sure that you know what that notation means. Now let's look at some graphs of functions. Consider, I'm going to give some information about people and their heights. So here I have Joe, Amy, Bill, Ryan, and Tom. So let's think about this. Is theirs actually a graph? Or is this a function? Well, of course it is. more than one person cannot have two heights. That just doesn't make sense, right? But if we look at the graph the other way, so if I put height on the x-axis and the people on the y-axis, notice how there is more than one height at 5. So that won't work. That's not a function because the x values are lined up vertically with one another. Well, this helps us actually figure out if I have a graph, is it a function or not? And it's called the vertical line test. You may have heard this before. The vertical line test is basically tells me a relation is a function if a vertical line drawn through its graph passes through only one point. So if it passes the vertical line test, I'm only going to hit the function once. So how are you going to do this? You're going to take a pencil and you're going to move it from left to right on the graph. If it crosses more than one point, it's not a function. So let's take a look and actually see how this is going to happen. So we're going to look at that graph that we just had recently, okay? So here's my pencil. I'm going to drive it along. Didn't hit any points there, so we're okay. Put my pencil again. Notice how I hit 2 points at the exact same time. So my question is this a function? Well, it failed the vertical line test, right? The vertical line test tells me I can only pass through 1 point. So this can't be a function because I passed through more than 1 point. So let's take a look at it again. What about this line here? Am I going to pass through that line more than once? Let's take our pencil and find out. So there's 1. I only hit 1 point there, right? Right there. Only hit 1 point. So is this graph going to be a function? Well, of course it is. It passed the vertical line test. No problems there. Let's take a look at the last example here. So I have this really awesome circle. Let's see. I'm going to take my pencil. Oh, hit 1 there. Okay, let's see. That's still okay then. Let's keep going. I'm hitting twice there. So is this graph going to be a function? No, right? I hit twice on my graph. It cannot be a function if you hit more than once with your pencil. And that's the end of this video. This is Miss Marsh signing off.